What if I told you the reason most beginner C++ developers struggle has nothing to do with writing code and everything to do with understanding how objects actually think? Today we're diving into the advanced pillars of object-oriented programming, the concepts that finally make C++ click: inheritance, polymorphism with virtual functions, abstract classes, interfaces, static and dynamic binding. These ideas are the foundation behind every professional game system, every Unreal Engine class, and everything you'll build as your projects grow. By the end of this lesson, you'll know exactly how these pieces fit together and how to use them to structure real gameplay code. This is the Game Creator Accelerator channel, and I am Tony Munoz. Like, subscribe, comment, share, and ring the bell so you can continue this C++ full free course here and get more Unreal tutorials and inspiring strategies to build your path as a game developer. Now let's continue. The first concept we're going to cover is inheritance. Imagine you are building a game and you have different types of characters. You have a player, an enemy, a boss. All of them walk, jump, and take damage, but each of them may do it differently. Instead of writing the same code in multiple classes, you put the shared behavior in a single base class, and then let other classes inherit from it. Inheritance means one class receives the properties and functions of another class and can add more on top of it. Let's create a simple example for inheritance. Start a class called character. And inside that class, let's define a public section and a method called move. Std, cout, and the characters move. This is what we call a base class, and we can use it as a reference to create other subclasses or children subclasses. For example, let's say I create the class player, which is of the type public character, which is the class that I previously defined. Now I can also have inside a public section and add other method, let's call it shoot. And of course I can do std cout, and let's say player shoots. The player class, because it's a child of the character class, can add an extra method. You can see that we do not use the move method inside the player, but we can use it every time because player is of the type character. Let's do a simple example. I can add a player, let's call it player, and then I can call for the player the method move, and I can call for the player also the method shoot. Let's test it. And here you have, well, the hello world at the beginning, and then the character moves and the character shoots, which are the two cout from the different methods. I'm going to name all this to make a comment for inheritance. The next subject I want to cover is polymorphism and virtual functions. Polymorphism is a long word that simply means different classes can behave differently through the same function call. This is how you can write a flexible and reusable code. And to enable this, you need virtual functions. Let's go to an example. First, let's add the note of polymorphism and virtual functions. Let's create a class named animal, a public section, and we add the virtual void speak. This is the biggest difference between how we declare functions before and how we do it with polymorphism and virtual functions. We add before the void or of the type of returning from the method a virtual. Let's add a standard cout. And we add the animal makes a sound. And now let's add a derived override. Look at this. Let's say class dog, which as you can imagine is of the type animal. And let's go for a public section and add void speak override. and then standard cout dog barks. Imagine that the class animal defines the speak like in a general way, but then you can create a child of that class, in this case dog, and take the same method and saying, yeah, but I'm going to implement it in a different way. That's why we use the override. Let's show it let's complete the example with an integer main and create an animal. Let's call it A equals new dog. And then we can say A speak. This is a very interesting example because as you can see, I store a dog inside an animal pointer. Even though A is typed as an animal, the program calls the dog version of speak, which is this one. This is dynamic behavior. This is polymorphism. This is how Unreal lets different actors respond to the same event in different ways. Let's test it. Here we have it, dog barks, which is this cout. If you remove the virtual, the base version runs every time, even if the object is actually a dog. This, by the way, is a beginner trap, so always pay attention to virtual and the override. Let's comment this section. And the next concept we'll cover is called abstract classes. An abstract class is a class that cannot be instantiated. You use them to define a rule or a behavior that all child classes must implement. You create them using a pure virtual function, which means a function without a body. Let's go for an example. Let's create the class weapon with a public section, and you define virtual void fire equals 0. This set this as a pure virtual. What does it mean? When you write the equal to 0, you are basically telling C++ this function must exist in any child class, but I'm not giving it a default implementation. Now let's add another class, which is called gun, which is a child of weapon. Define the public section and void fire override and standard cout gun fires bullets. Let's add an integer main. And now let me show you how you're going to present an error or not. You can define a weapon, let's say W, and this will generate an error. Why? Because this is an abstract class. Here's the error. Abstract class. Object of abstract class type weapon is not allowed. Function weapon fire is a pure virtual function. So how should I do this correctly? Let's create a weapon with a pointer W, new gun. And now I can use the W and fire that gun. Let's run. Here we have it, gun fire bullets. Abstract classes are essential when you want a base structure for your system, but each derived class provides its own behavior. In Unreal, many core systems rely on abstract classes so developers can create their own implementations. Before we continue, I want to share something important. In the Game Creator Accelerator Lifetime Mentorship Program, the focus is on real transformation you can achieve in just a few weeks that will support you for the rest of your career as a game developer. You and I work together to build your first playable prototype in Unreal, set up your social media platforms to attract attention, and establish daily routines and strategies that keep your inspiration high and your progress visible. This is the same system that successful independent creators in the industry use. It is the same approach that helps you start building a business model around your game while also positioning for your job opportunities, if that is the path you want to explore. Because in today's industry, applying to jobs alone does not work. Hacking the system is about showing consistent progress, sharing what you create, and letting studios or players come to you. And they will. because you will learn how to create your brand and you will have a selected community and me around you week after week. Yes, with lifetime access. Where else can you find that? Want to know more? Visit the link in the description. The next section we will cover is interfaces. Interfaces define a set of functions that a class must implement, but they contain no code at all. Unlike inheritance, using interfaces does not define what the class is, but rather what the class can do. An example can be a door can be opened, a button can be pressed, a chest can be interacted with. These objects may not share a base class, but they all can implement the ability to be interacted with. C++ does not have native interface syntax, but we simulate it using classes with pure virtual functions. Let's create an example. Let's say class I interactable. Public section, virtual void interact equals 0. Now any class can implement that interface. Let's say class door public I interactable std cout, and let's test it with an integer main. Create an object door. Let's name it my door. And now I can use my door to call interact. Because door implemented the interact, the function will present door opens. Let's check it. Door opens. Interfaces are extremely important in Unreal. This is how actors can react to gameplay events without forcing everything to inherit from one specific class. Interfaces lets your architecture grow without breaking your inheritance hierarchy. Probably at this point you are a bit confused between abstract class and interfaces. C++ does not have a dedicated interface keyword like C# or Java. Instead, both concepts are implemented using classes, but with different intentions and usage patterns. Let's break it down clearly. An abstract class is a class that can have pure virtual functions, can also have regular functions with implementation, can have member variables, and may contain a constructor and a destructor. It cannot be instantiated. If we go back to the example of the weapon, this abstract class, we could also add a void, let's say a method named reload, which is a normal function. You can have also a protected section, for example, where we add the ammo, which is a data member. And then, for example, I can call w reload. And it is not a conflict because the reload section is a normal function. If we play it, here we got gunfires, bullets, and reloading. Now let's go back to the interfaces. An interface in C++ is simply a class that contains only pure virtual functions, has no data members, has no implementation, should not have a constructor, and exists only to define behavior that a class must support. The real difference in one sentence is abstract classes define what something is. Interfaces define what something can do. In the abstract classes, you can have a partial implementation. You can give child classes both rules and working code. In interfaces, you have zero implementation. Only rules, no code, no variables, no construction. Just a pure contract that classes agree to follow. Now, let's talk about static versus dynamic binding. Binding refers to how the program decides which version of a function to use. There are two types. The static binding, which happens at compile time, used by non-virtual functions, is faster and simpler, but it's not flexible. And we have the dynamic binding, which happens at runtime, used by virtual and override functions, allows polymorphism, and it's slightly slower but essential for gameplay logic. Let's create this example. It is a bit longer but essential. First, I'm going to include the IO stream, and let's start with the class animal. Public section, a void, speak static, std, cout, animal, static, speaks, and another virtual void, speak dynamic, std, cout, animal, dynamic, speaks. The first one is a non-virtual function, static binding, and the second is a virtual function, as you can imagine, dynamic binding. Now let's create a child class from animal. I'm going to copy this one to make the process easier, and let's rename this class dog of the type public animal. And let's make some small changes. The virtual will be removed, and let's change this to dog static barks, and here dog dynamic barks. This one hides animal speak static, and this one overrides the virtual function. Now let's implement the integer main. Let's create a dog of type dog, and now let's add a direct calls, no pointer involved. We can take the dog and go speak static, which is the dog version, and I can also speak dynamic, dog version. And now let's add a pointer to base class. Let's say animal, which is the base class, animal pointer equal to dog. And now let's talk about the static binding and the dynamic binding. For the static binding, we use animal pointer and call speak static. And for the dynamic binding, we use the animal pointer and call the speak dynamic. And of course, return 0. I don't have to do it, but it's good. Let's run it and explain the details. When a function is not virtual, C++ decides which function to call at compile time based on the pointer type, not the object type. If we go to the button, animal pointer is of the type animal pointer, so it calls animal speak static, even though the real object is a dog. Static binding is fast, but not flexible. Now let's cover the dynamic binding. When a function is virtual, C++ decides which function to call at runtime based on the actual object, not the pointer type. In the case animal pointer speak dynamic, the object is a dog, so it calls dog speak dynamic. This is the foundation of polymorphism. One sentence summary could be: static bindings calls the functions based on the pointer type. Dynamic binding calls the function based on the actual object type. Think of a static binding like a fixed road. Your car can only go where the road leads. Dynamic binding is like a GPS rerouting. At runtime, based on what object you actually have, the program picks the right destination even if the pointer type is generic. Today you saw how advanced object-oriented programming concepts are not just theory, but the structure behind real games and programs. You learned how inheritance lets you create families of classes that share behavior, how polymorphism and virtual functions let different objects react in their own way to the same call, how abstract classes define rules and blueprints for your systems, how interfaces add capabilities like interaction without breaking your class hierarchy, and how static and dynamic binding decide which function actually runs under the hood. My recommendation now is simple. Do not just watch this once and move on. Pick a small idea like a group of enemies, weapons, or interactable objects, and recreate these concepts in your own code. Make a base class, add a couple of children, implement an interface, use virtual functions. Then break things, fix them, and read the errors. That is how this stops being theory and becomes a skill. Now help me expand the presence of this channel so we can reach more future game creators. Like the video, subscribe to the channel, leave a comment telling me what you are going to build with these concepts. Share this with a friend who wants to get into the game development industry, and ring the bell so you do not miss the next episodes of this full C++ course and the real tutorials that goes with it. Until next time, keep creating, keep sharing, and most importantly, keep dreaming big. I'll see you soon, my fellow creators.